Okay, so yeah, lovely to see everyone here again today for week 3 of the Cross Society Python course, jointly run by UWCS, the Coding Society, and Warwick AI. So we'll be covering data structures today. So that includes lists, tuples, and dictionaries and how they differ. We'll be covering string slicing as well as list splicing as well. So that's kind of like ways to manipulate these data structures, which we'll kind of go into a little bit more detail on later on. And as well as that, we'll cover some loops. So that'll just be your standard like for and while loops. So yeah, we'll just jump straight into it. We can start with what is a list. So a list is essentially like a container, and it can store literally anything you want it to, and it can store it under one variable name, and that's the important bit. And so the way that you write this out is that you need to start the list with a opening bracket, so a square opening bracket, and end it with a square closing bracket, and you can put whatever you want inside of that. So this can include like ints or strings or floats or like your own custom data types, if you've been familiarized with that from sessions beforehand. And you can just put whatever you want inside of it, and you can mix and match as well. So that's the cool thing about Python. In terms of how to like get things within these, you'd have to use what we call an index. And what an index is a way to access elements at certain positions. But the thing with lists in Python is that they start with index number 0. So your first element, where you'd call that usually number 1, that would be index number 0. And so the way that we access it there, if you can see on the slides, it will be 1_2_5, so that's the variable name, and then in square brackets, the index, which is 0. And so that will print the number 1, which is the first thing in the list. And as well as that, we have print 1 to 5, 4, which is the last thing in the list, so the 5th element. So yeah, we'll just go through an example right now. So you can see what we have here is it's a list of strings of just random toys that I picked. What would you guys think would happen if we ran print toy box number 2? It would, I believe. And what do you think about print toy box 5?
Error.
Yes, it would be an error. Why? Yes, that is correct. So that's the example of what we have here. So moving on to another example. We've got an empty box. What happens if we run print empty box 3?
Error again.
Why is that? And what about the bottom one?
I'd say error again.
Yep, you're right on both again. That's why. Does anyone have any like questions about that? That kind of makes sense? Okay, cool. Let's move on. So one cool thing about Python is you can also index from like the back of a list. And so what that means is where usually you'd go up in increments of 1, so like you'd start with 0, then you go to 1, then 2, then 3. To go forwards, to go backwards, you just need to use negative indexes. So for example, we can run print toy box and then -1 to get the final element from the list, and that will just be bare. And now moving on to string splicing, this is kind of like an extension of this like backwards indexing, and it's like it allows us to manipulate lists in different kind of ways. And so the way it works is that you have 3 parts of a splice. So you have the start index, you have the end index, and then you have the step. And you can go through your list in like loads of different ways with this, and you can limit like what's seen by whatever you print. So for example, on the right hand side, you can see I've got a print toy box and then : : 2. When there's nothing between the colons, that means it's essentially the default value. And so for start, that will be 0, and for end, it will be the last element, and then 2 is the step. So if we're going to run toy box and then : : 2, what that's going to do is it's going to look at the first element, and it's going to print that, then it's going to go 2 elements forwards to Lego, print that, and then do the same with bit. Similarly, you can see when we've got toy box and then 0, : : 2, that's as if we're saying that there's no like end index, and then that takes a default value of just what the end of the list is. So that's going to print the same thing. In the third example, we've got toy box 1, : 2. So that means we're going to start at index number 1, and then we're going to step forwards 2 elements. So that's going to print Nerf gun, and then it's going to print 3DS. And then at the bottom, we have another example as well of just ignoring the final element, the step. And if you ignore the step, in this case, it's just going to default to 1, which is just go forwards by 1 element and print the first 3 elements there. As well as that, you can also index on strings, which is what I've demonstrated on the bottom left. So you're given a string like A, B, B, C, C, D, D, and then you can index here just like literally anything you want. And what this does in particular, in fact, would anyone want to explain that? or I can do it myself. Okay, I'll do it. So it starts at index 0, and the -2 means you ignore the last 2 elements of the list. So that means you're going backwards 2 elements from whatever the end is, and that's the same as what we had before, which is like the reverse indexing concept. And then 2 is the step. So that means we skip every second element. So that will print the first element, the third, and the fifth, and ignore anything else after that. Okay, so these are some examples of other list operations that we have. So you can actually add to the end of lists because they're what we call mutable, and what that means is you can just basically change what's inside of them. So you can add things to the end with the dot append. So if you have a list, you can write dot append on that list, and it will add this element that you put inside of the brackets to the end of the list. You can also sort lists, and you can also remove elements or insert elements. Inside of the worksheet that you guys will have later on, it will kind of go through all of these like little finicky details. Something interesting that you have in Python is that you can put lists inside of lists. So earlier, I spoke about the fact that you could put anything inside of a list, and that just does include lists itself. So here we've got a nested list, and if you notice, there's 2 like opening square brackets, and what that means is that there's a nested list of elements 1 and 2. So if we're indexing on nested list and then colon 0, that would look at the first element of the nested list. And that isn't just 1, it's going to be 1, 2, because we've got to look at like each element separated by the outer comma. And then if you also similarly did like nested lists and then indexed on 1, that would print out 3 and 4. So then you can look at also indexing lists inside of lists, which should be the bottom line there. So print nested lists 0, 0, which would print out literally just the number 1. Something different about Python is that it also has a data type called tuples, and it can also hold any kind of like data you want, but it can't change. So whatever's inside of that is static. And so that means like you can't adjust it, you can't like assign it to something else, you can't like append to the end of it. So it's just what it is. So you can print out like just as normal as you just index it like you would a list, but what you can't do is assign. And what I've tried to do at the bottom there is just assign and append, and both of these will throw errors because you can't like change tuples. Another data structure that we have, and the final one that we'll talk about today, is a dictionary. And so this is literally like exactly what the name says, and it's that you can look up the definition given like some kind of value. And formally we call that just a key value pair. So with a key, you can get some kind of value. Here our dictionary says like first name and then colon Alex. That means when you call my dictionary with first name, it's going to give you back Alex. And for last name, it's going to give you back Doe, and for age, it'll give you 20. And so then you can index it as below. So on the bottom line, I've got a print statement there. And so what you do is you have the list name, or sorry, the dictionary name, and then in the square braces, that's where you just put whatever your key is, so whatever you want to access into. So first name. Also, you can't just, it's not the case that you only need this with strings. It also works with things like int keys or float keys. So if you wanted to have like 1:5, then you could also do that as well. And yeah, now we'll move on to loops, which is moving slightly away from data structures. So yeah, the reason why we have loops in a programming language in general is because we want to try and avoid repetition as much as possible. So for example, let's say that what you wanted to do was print the numbers 1 to 100. And if you want to do this manually without a loop, you'd have to go through each statement and do print 1, print 2, print 3, print 4, print 5, and then go all the way to 100. And obviously this is really long, so you want to try and avoid that at all costs. And we can do this through a couple of different methods, which I'll go through now. So the first loop type that we'll go through is called a while loop. And what that means is that it literally just is as it reads, right? So while some statement is true, you can execute what's underneath it. So you can consider it as if, like earlier in the lessons, we talked about expressions and Boolean expressions in particular. And what a while loop will have is an expression that will either evaluate to true or false after it. So here we've got while count is less than 10. Count is less than 10 is a Boolean expression. So at the very start, count is 0. So that is less than 10, so it will execute what's following. And until that statement is false, it will keep repeating itself. So yeah, that's what happens here. So it will execute print count, and then it will add 1 to itself. So that will print 0, 1, 2, 3, all the way up to 9. And then when it gets to 10, it will stop, because at that point that count equals 10, it's not less than 10, so it's going to break out of the loop. Yeah, so when you do while loops, you've got to be quite careful about what you do, and just basically kind of know what the steps are that the loops take. So Does anyone know what the first while loop would output here? I'll just give you guys a couple of seconds for that. Anyone have any ideas? Yeah, that'll be nothing. Why? Yeah, it's false. So it's just not going to execute the loop at all. What about the second one?
Infinitely many numbers.
Why is that?
Oh, well, from 20.
Yeah, why is that?
It's always going to be bigger than 10.
Yep, that's right. So it's just going to keep going until you like X out the program, basically. So you want to avoid like situations where your loops continue going on forever, unless it's like obviously intentional, but most of the time it's not. So you need to be sure that your loop will have some kind of like termination point. Something interesting about termination points is that we have a concept of a for loop, and a for loop is a kind of, it's very, very similar to the while loop, but you'll use it in kind of different contexts, and it is, you could kind of consider it an easier way to write a while loop. So with the while loop earlier that I showed you, you'd have to write like count equals 0 and then while count is less than 10. With a for loop, you just write for I in range 0 to 10. And it's a lot more concise, and you can do it all in one line. It looks a lot nicer. So on the top right here, what we have is an example. So that'll print for I in range 1 to 6. And so what that means is it's going to start at 1, and it's going to increment 1 until it gets to 6. And at the point 6, it's going to exit. And that means it breaks at 6. So that means it's going to print I equals 1, 2, 3, 4, and 5. Similarly, you can also use for loops with just straight up lists. So that's what the bottom example is, and that's for I in 1, 2, 3, 4, 5, and then you can print I, and it achieves the same goal at the end of the day. An interesting thing that you can do is also iterate over variables that Python calls iterables. So here we've got some items, and it will have like 5 strings, and you can actually loop over this container, right? So you can put for s in some items, and you can print each one, and it'll print out on a new line. There's also other things that you can iterate across. In fact, there's lots. One of them is a dictionary, and so this is how you do it. So you can like say you're iterating over like the key value pairs that we spoke about earlier. So that's like whatever you want something to mean, and that's what I've done here. So I've said hello is a greeting, and then age is a number of years someone is alive, blah blah blah, as my dictionary, and then I printed out underneath. So that's for word and definition in the dictionary.items. So you have to use this .items concept to access the word and definition and unwrap them, essentially. And so that will just print them as you'd expect there. So something interesting with loops is that sometimes you'll have conditions where you'll want to exit them early. And when you want to do that, you want to use a break or a continue. So in particular with break, that will literally just exit early, and there's nothing really like that complicated about it. So you'd start at some number, and when some condition that you say evaluates to false, or like maybe you just put a break somewhere else, then it will just exit out the loop straight away. As soon as it comes in contact with that break, it's going to exit out of the loop that it's inside of. Similarly, but kind of differently at the same time, the continue statement, what it will do is it will just skip that iteration of the loop. So what that means in context is that compared to a break will just exit out, whereas a continue will just like ignore the rest of the loop contents and then just go to the next iteration. And so what that will mean is that if we have like for I in range 0 to 5 here, if I mod 2 is equal to 0, so that's if it's an even number, then we want to skip that loop. Otherwise, we print it. And so let's just step through the program. So if we start at 0, that is an even number, so we're going to continue. And if it's 1, then it's an odd number, so it's going to print the bottom line f is odd. I is odd. And then 2 is even, and then it's going to ignore that. And then 3, it's going to print again 3 is odd. So that's kind of like an overview of break and continue. Yeah. Anyway, that's kind of like the end of the presentation. Here you can access the worksheet for today.